Everybody, we have this question about biochemical oxygen demand. We have a wastewater sample has an oxygen demand of 5.2 milligram per liter at 5 days and 9.5 milligram per liter at 20 days. If the base 10, the oxygenation rate constant is 0.1 at 20 degrees Celsius, and this is our KD value, or the deoxygenation rate constant. The amount of oxygen demanded by autotrophic bacteria in the nitrification process, milligram per liter, is most nearly. So to solve this question, let's see how the biochemical oxygen demand develops with time. So here are our axes: time versus biochemical oxygen demand. So the growth of BOD takes an exponential shape, exponential curve, and it continues to grow until it reaches a constant value which called the ultimate biochemical oxygen demand. So let's say here is our 5 days BOD, 10 days, 15 days, and 20 days biochemical oxygen demand. So at a certain point of time, here for example, there will be addition to the growth of the BOD exerted by the autotrophic bacteria in the nitrification process. And this will make a jump in the curve like this. So any addition here to the growth curve will be due to nitrification process. So on the equation for this curve here, is BOD at any time equals the BOD ultimate times 1 minus 10 to minus KD times T. And this T here is the same as this T here. So we can apply this equation for any value of time on the T-axis. So let's apply this equation for the 5 days BOD. So this will be 5.2, which is given the question. The oxygen demand is 5.2 milligram per liter at 5 days. This will be equal BOD ultimate times 1 minus 10 to power minus, and KD is given in the question statement as 0.1 times, and this time is, we are talking about 5 days BOD here, so we'll take this as 5. And from this equation, we will find our BOD ultimate value as 7.605 milligram per liter. Now we can apply this equation again for T equals 20, and this will be our BOD ultimate, which we just calculated here, times 1 minus 10 to minus 0.1 times, and now T here is 20. and this will give us our BOD 20 as 7.529 milligram per liter. Now we have two values of BOD 20, one calculated from the curve, this value, which we just calculated here, and we have this value here, which is given in the question as 9.5. So the difference between these two values, so the delta BOD 20 will be 9.5 minus 7.529, and this will be 1.97, almost 2 milligram per liter, and this is the difference in the BOD 20 and represent the addition to the biochemical oxygen demand exerted by the autotrophic bacteria in the nitrification process. So if we look at the solution options, so this is answer C.